So what we're going to be talking about today is ecospheres. And so do any of you know what an ecosphere is? So an ecosphere is a self-sustaining little bioactive terrarium. In this case, it's a marine terrarium. And so there's many different ways that things that can be called an ecosphere. And so there's some that are plants and mosses, some that are freshwater, and some that are saltwater. And so today we're going to be making a saltwater ecosphere. And so with the proper light and temperature, it shouldn't require any outside interference other than that. And so it should be its own self-sustaining ecosystem if it's set up properly and is able to get itself cycled and working. So like an example of that is this, in this water bottle. This has been going for about 2 months. And it's doing really well. There was a snail in it, there's all kinds of things, little copepods and other little planktonic life living on the plastic, and so it's doing pretty well for being 2 months old. And so that's when it gets kind of exciting, because you're like, oh, I have this little ecosystem that I can have just sitting on your window. And like that, it's literally in the window in the office, and it just gets a lot of light in the day, and so it's doing well. And so with the perfect conditions, they can last indefinitely. And so like there's a terrestrial ecosystem that's a guy made that's been going for like 68, 70 years. It's the longest lasting one where it's completely sealed off. And so with this, for the ideal way is that you never have to open it up. And so you may have to open it up at some point to like take out something that's died, like if some of the seaweed dies or something, you can take that out, because if you don't, it'll cause a lot of problems for the ecosphere because it overloads it with biomass. So the bioburden is too high. And so with this, an ecosphere, like I said, it acts as its own self-contained ecosystem, and there's 2 different factors that come into play. They're biotic and abiotic. And so biotic factors are living factors, and abiotic factors are non-living factors. And so the goal of this is to simulate a large ecosystem on a really small scale. And so like with these, we're basically replicating the intertidal zone, or the like subtidal zone, that's the very shallow subtidal zone, because it's constantly underwater, but it still gets a lot of light. And so are you all able to tell which of these are biotic versus abiotic factors?
Which is what now?
With like the air, light, plants, temperature, water, algae, soil, and bacteria, what is an abiotic factor versus a biotic factor? So what's considered a living factor versus a non-living?
The abiotic would be anything that's dead in there, or the air between the top and the biotic? I'm not sure.
So an interesting thing about the biotic factors is that even if an organism dies, it's still considered a biotic factor because it still is organic matter. And so if we look here, the biotic factors are the plants, algae, and bacteria, whereas the rest of this is all abiotic factors. And so even if the plant dies, because it's an organic material, it's still a biotic factor. So the soil, when it's like here, it's sand and shells and rocks and other things like that. That's an abiotic factor because there's no organic matter. In something like potting mix, it has a lot of biotic factors in it because of like worm castings and coconut fiber and a lot of things like that, like barks and stuff. Those are all biotic factors, even though we don't think of it as something alive.
So are you thinking of organic as like chemistry organic, so like carbon based, or are you thinking just like it's been alive at some point?
It was alive at some point. And so it kind of, it gets a little fuzzy when you really like sort through it, just because then you start getting to things like viruses. Is it biotic or is it abiotic?
So is this, I mean, the terms are just fuzzy in themselves, right? Biotic, like
It's not so much that terms are fuzzy, because the terms are very like, this is alive, this is something that has never lived.
Mm-hmm.
It's just some things, they kind of cross into both, and they have attributes of both, and so it gets hard to classify. And so next I'm going to talk about some marine ecosystems, and so some of the different types that we have around here, just the basics of them. And so the first thing I'm going to say is what comes with the sand and water that we'll be using, because there's all kinds of microfauna and macrofauna that live in this sand and water. And so the microfauna, so these are so small that you can't see them with the naked eye, so they're less than 0.4 millimeters in size. So these are things like diatoms, fish larvae, shrimp larvae, fungi, and bacteria. Most of the time you can't see these. Something like the diatoms, like if you were to come right up here, which you guys will see later, you can see like the little tiny dots in here. Those are diatoms, but they're so small that you just see a dot. You can't really see any other detail because it's just a speck in the water. And so these are also things like marine fungi. This is a mantis shrimp larva. These are examples of diatoms. So like you'll mainly be seeing these circles is what we can see because sometimes they get bigger. And then like that's a fish larva. And so then there's the macrofauna, and the macrofauna is slightly larger. And so their size ranges from a few millimeters to a few centimeters. And so these are always visible to the naked eye. And so they also only live in the sediment. They live in and under on the surface. So these are worms, clams, snails, many crustaceans, sea stars, anything like that stays small enough. And so these are things that could be hitching a ride in the sand. So like with this, like if you took a scoop of sand, there is most likely some macrofauna living inside of that. And so part of why we're doing this with the sand, this sand and water and the algae and stuff, this all came from the beach right out there. And so we're taking the natural organisms that live in this to replicate this exact ecosystem. And so the basics of an ecosystem are the biotic factors, like I was saying. So these are like producers, which are plants, algae, and phytoplankton, and consumers, which are fish, crabs, whales, zooplankton, anything else that doesn't produce its own food for itself. And then there's microbes, such as fungi and bacteria. And so then there's the abiotic factors. So these are things like sunlight, minerals, dissolved oxygen, temperature, depth, currents, and other things like that. You can also classify viruses as an abiotic factor, but that's one of the things where it gets hazy because there's a lot of debate over is a virus something alive or is it something that has never been alive because it exhibits attributes of both. And so that's why I left it out because it kind of covers both of them and there's so much debate going on between it. And then so the types of marine ecosystems, this is just kind of the basics of what we have around here and what you can replicate with this little ecosphere. And so the estuary and salt marsh, this we can't replicate with it just because it has to have changes in salinity throughout the day and a lot of things like that. Because as the tide goes in, the salinity gets higher. As the tide goes out, the salinity gets lower because it's where fresh water and salt water meet. And so it has a lot of change throughout. And so the organisms that live there, they are very well adapted for that fluctuation in salinity. And the salt marshes and estuaries are crucial for many fish, birds, mammals, other things like that, because they act as feeding grounds and nesting grounds. And nurseries. They also filter out pollutants, which is extremely important because of the runoff. So just like marshes and other things like that, it's just salt water instead of fresh water. So then there's soft bottom ecosystems, and so soft bottom ecosystems have either sand or silt as their bottom. So like out here, it's mainly a soft body ecosystem because if you dive here, it's really silty often, and so that's mainly what it is. And so there's very little places for things to attach to because they like sponges, anemones, corals, everything like that. They need hard surfaces that don't shift around a ton to attach to. And so like diving out here, you'll see all the anemones, they're clumped up on things that have been put down in the water or are just naturally there. Like there's a small boat that's down there that is got a bunch of anemones and other things on it because it's a hard surface that doesn't move. And so they often look barren, but not always, because things like eograph beds, which we also have here, they're a type of plant, and so they grow into the soft sand and are able to root in there and stay in place. In these ecosystems, animals also tend to bury themselves because they're able to get that silt or sand up over them, whereas if it's like a bunch of rocks, they can't really do that. So think of like flounder and other flatfish, how they'll wave and then move the sand over them. That's because of the soft bottom. That's why they're able to do that. So then there's rocky bottom ecosystems, and so these tend to be the more like diverse and have higher biodiversity, and they're a lot more interesting to look at most of the time, just because there's a lot more there. So that's where things like kelp forests, they're able to grow there. And so compared to the rest of the ocean, kelp forests are actually extremely shallow water because they only go to about 131 feet down, because then there isn't enough light. Some of them are deeper, some of them are shallower, that's just an average. So then there's coral reefs, and so something that's like a true coral reef that we think of as like the hard corals, it has to grow in rocky areas because it needs that structure. Because they're so slow growing, and if things start shifting around, it can hinder the corals and harm them. And so that's why if you see like pictures of like reefs in tropical places, you'll see, oh, there's all these rocks and the corals growing over there, but then there's paths of sand through it. That's because the corals don't grow onto the sand. They'll grow off of other corals, but they don't sit on the sand and grow, because then it doesn't work right. And so there's a lot of stable attachment sites. There's also open water, which is anywhere in the water column. So a lot of these organisms, they don't ever actually come in contact with the seabed, the surface, or the shore. They spend their entire life suspended in the water. So things like jellyfish, anglerfish, vampire squid, and then the whale sharks, like they're pelagic species, so they don't come in contact with the bottom most of the time, if ever. And so this contains the smallest animals to the largest animals in existence. And so it goes from the tiny zooplankton and phytoplankton all the way up to the blue whale. And so it really shows how diverse these ecosystems can be. And while people think of it as barren because there's nothing for fish to hide behind and hide under, and so they're really spread out, it has an insane amount of diversity, like and so now you guys get to build your ecosphere and decide yourself. So there's a couple different things that you can try to do. So do you want it to be just a lot of sand? Because if there's a lot of sand, there's a lot of microorganisms, but not all that much algae, so it just is going to be a little bit of sand in a jar, and you'll see all these little animals, but there won't be the green algae. You want to have a mix of sand and rocks that make it kind of a mix of the two, because then you can have a little bit of algae, and so then you can, and there'll still be a decent amount of microorganisms. If you want it to be just rock, there's going to be less microorganisms, but you can have a lot of algae. And then how much algae do you want? If you want a lot of algae, you need to add more rock. If you want only a little bit, you need to add less rock. If you want none, you can just add sand, or you can pick through the rocks and take pieces that don't have any algae on it.
I have a question. So, as we're going through this and our ecosystem is growing, can we change it? Will it change, like, if we add more rocks to it later on?
So you can add, if you wanted to, you can add more later on. If you have it growing and it's stable, I don't suggest messing with it, because it'll throw it off, and then you could have something that like, oh yay, it's been growing for months, I'm gonna put this one little thing in, and it just dies because it upset the balance. Because they take a little while, so like when you first put it in, don't let it get sitting. If it starts to kind of look crappy after a couple days, don't just throw it out. Give it like a month, and then if it's still not doing good, you can start over and make another one. Because that's the nice thing about this. The only thing that you have to pay for is a jar. The rest of it you can literally go outside and find. And so like I love making the sealed terrariums. And so I literally go out into my backyard, I pick up some sticks and dirt and plants and put it in a jar and mist it and then seal it up, and then I've got a little ecosystem. Sometimes they work, sometimes they don't. Saltwater is one of the more hard ones to get to work, just because it seems like everything that involves saltwater animals is a lot more picky and finicky. But if you decide, well, I don't really like the salt water, there isn't that much in it, I can't really see much, everything's really little, you can always go to a pond and fill that with water and some soil from it. And those ones do really well because they're used to stagnant water. Whereas the salt water, part of the problem is that it's not moving. And it's like here, the water's always moving, it's going in and out, and there's currents and all kinds of stuff, so it doesn't sit stagnant. And so if you guys want to, you can come up here and you can take the sand and water and the rocks, and there's also some shells here. I have a couple examples if you guys wanted to look at those. So I got these two here, and then I've got some diatoms and other phytoplankton in here that we'll add at the end because it gives it a nice boost for the basics of the ecosystem so that it kind of sets it up for success.